Hey guys, in today's lesson we'll be calculating the rate of change of a linear function. Let's quickly look through some definitions real quick. There's not many of them in this lesson, but a linear function is a relationship with a constant rate of change represented by a graph that forms a straight line in which each element of the input x is paired with exactly one element of the output y. So we got our different methods of finding the rate of change. You got your tabular method, which is the change in y values over the change in x values. That can also be represented with m equals, see this triangle y, the triangle means change in, so change in y over the change in x. Or we can write it as m equals y2 minus y1 over x2 minus x1. Don't let these y2, x2, or y1, x1 confuse you. They're just naming points. We'll look further into that as we go through this lesson. The graphical method is if you're given a graph, the easy way to find the slope is just do rise over run, aka the slope is also known as your rate of change. Algebraically, if your equation is in slope-intercept form, such as y equals mx plus b, you can just solve for the equation y, which this one already is, and slope is represented by the m value. So that value right next to the x will be your slope. Okay. So getting into this, let's just look at a couple examples here and what I'm talking about. So if we went by change in y over change in x, I can see my y here, and here's my x. And if you notice, from 4 to 8, that's a change of a positive 4. And from 5 to 10, that's a change of plus 5. So if we went with slope equals change in y over the change in x, we would see the change in y, of course, is that positive 4 value, so 4, and then over that change in x, which is 5. So our slope here would be 4 over 5. And it's already simplified for us, so that is what we have. Okay, you're looking at it graphically, you can see the point 5. I'm sorry, real quick, let me erase this real quick so we have a more clear view. We see the point 5, 4. Let's go to our graph 5, 4. It is graph for us, annotated with the b value. And 10, 8 as another point. So going over 10, 8, annotated with the d value. Okay, graphically, we can find the slope by doing the rise over the run. When we talk about rise, we're talking about up or down. When we go up, it's positive. Down means negative. So we're going to go up 1, 2, 3, 4. So once again, slope equals rise over run. And let me give myself a little bit more room there, guys. Let's see. Rise over run. Once again, it represents slope. So we see that once again that our rise was 4. So we're going to go ahead and put 4. And we went up 4, so positive 4. And then our run, left to right. Once again, going right means positive. Going left means negative. We see 1, 2, 3, 4, 5. So 4 over 5. Once again, that is our slope. Okay. Moving on down. I'm going to ignore some of these. A little bit harder to read than some of my problems later, and we'll look over that. But let's look at this other one. So you change in y over change in x again. Sometimes it's real easy to see. Sometimes we got to do it in another format. But our change in y, annotate with f of x, is like our y values. Negative 7 to 5. That goes up by, what, 12 units? So 12. And our change in x goes from negative 4 to 0. So that goes up by 4. So technically, our slope will be 12 divided by 4. And when we simplify that, we get 3. So our slope would be 3, or our rate of change would be 3 in this case. Once again, remember, rate of change is the same thing as saying slope. moving on. Like I said, I'll go over more of this when we're doing some of the problems. But real quick, let's look at one more rise over run. Real quick, I'm going to go from, we're going to look for 2 good points. And what I mean by 2 good points is we want our graph, our line right here, to intersect where our X and Y grid lines also intersect. So for example, some good points here would be like this guy right here, 6, 1. And we can even choose this guy right here, kind of close by. Looks like 3, -1. So we do rise over run, we go 1, 2, 2 up. So once again, 2 up, so annotated with a +2. And our run would be 1, 2, 3. So 3 to the right, so a +3. So our slope or our rate of change would be 2/3 in this case. And then shows it here, the example, rise over run 2/3. Once again, they chose different points, and you can choose any points that you want, as long as they're 2 good points, and you'll typically find the same result no matter what. All right. Moving on down. You can look these over if you want to. I'm going to go over some of these sample problems that we got here. So here it says, the amount of water that flows through the Hoover Dam can be calculated using the following formula, in which y equals the number of seconds and x equals the number of cubic feet. 6,000x minus 2y equals 0. What is the rate at which the water flows? So, pretty much the rate of change. So what we can do is find our slope. Now if we can get this equation right here into y equals mx plus b format, we can easily find our slope by looking for this value right in front of the x. So I'm going to take my equation, 6,000x minus 2y equals 0, and I'm going to solve for this y value right here. So in order to do that, we first need to move that 6,000x to the other side. So to move that whole guy over, we're going to subtract out 6,000x from this side. But what I do to one side, I must do to the other. So minus 6,000x. So of course, 6,000x minus 6,000x is 0. Those just kill each other. We're left with minus 2y equals, well, we won't combine this negative 6,000x with a 0. They're not like terms because this guy has an x, this guy's just a constant. But he is just 0, so we're just going to bring down that negative 6,000x. And now there's no need to write down minus 0, so we'll just leave we just won't write down minus 0 there. Lastly, to solve for y, we just need to get rid of this negative 2 in front of it. So of course they're multiplying to each other, so let's get rid of it by dividing by negative 2. Do the opposite of multiplication. So negative 2 divided by negative 2 is 1, which is kind of what we're trying to do, find is 1y or y equals. And then negative 6,000 divided by negative 2, well, negative divided by negative is a positive, and 6,000 divided by 2 is 3,000. So we have 3,000x. Once again, that number in front of the x is our slope, so 3,000 is our slope, aka also known as our rate of change. So A would be the correct answer choice, 3,000 cubic feet per second. All right, moving along. See what we got next. Let's see if I can, well, might have to scroll down after we read this, but it says 12 years ago, Jonathan planted a maple tree. He plotted the height of the tree at the beginning of every summer and connected the growth with a line. So this is our following graph. It asks us, how fast is Jonathan's tree growing? So once again, asking us for the rate of change. So if we look for 2 good points, we could easily find that rate of change. Once again, this guy's pretty good at 0, 0. And this guy at, well, 1, 2, 3, 4. 4 and 1, 2. So it's kind of easy to see that we go 1, 2 up. So once again, rate of change or slope is equal to rise over run. We see that our rise is 2, positive 2 since we went up 2. And our run would be 1, 2, 3, 4. So 2 over 4. Which of course that reduces down to 1 over 2. Okay. So it looks like our height of our tree is measured in feet. So it looks like for every 2 years, the years is our independent variable, or x. So for every 2 years, it goes up 1 foot. Okay. So 2 years, 1 foot. Let me rewrite that down. Our rate of change, or our slope, is equal to 1 foot for every 2 years, as annotated by our graph. Looking at our answer choice, it says 2 feet per year. Of course, we know that's not correct because we only go 1 foot every 2 years. Next one says 1 inch every 2 years. Once again, be careful. It says inch. We're going 1 foot. So he's wrong. We got 6 inches per year. Well, that kind of makes sense, but let's look at the last one. 1 foot per year. Once again, we go 1 foot for every 2 years, so he's wrong. So let's look at why C might be correct. Because once again, we go 1 foot every 2 years. But if we do look, we understand that 1 foot is also the same thing as 12 inches. So we go 12 inches every 2 years. Well, if we simplify that down, okay, we simplify that by 2, we'll see that we go 6 inches every 1 year, or 6 inches per year. So C is the correct answer choice. Okay, give y'all a second to sink that in. Hopefully y'all understand that. With graphs, it's really easy. Just do the rise over run. You could go any other. You could do change in y over change in x. Y2 minus y1 over x2 minus x1. It's all pretty much the same at the end of the day. All right, 3. We have a graph that shows how the mass of copper changes as the volume of the element changes and the density remains constant. Okay. We're asked to find which of these best represents the rate of change in the mass of copper with respect to the volume. So once again, we're looking for the rate of change, or aka our slope. So we need to find 2 good points real quick. And this one might be a little more complicating because everything looks a little bit further apart and it's harder to indicate these 2 good points. But as long as we find some decent points, we should get close enough to our answer choices. Just might have to do a little bit of estimation. So looking here, I think I'm going to go with this point right here, which would be, let's see, 4 to 5. We go 1, 2, 3, 4 over. So it looks like it's 4.25 here, 4.5 here, 4.75. So I see this point is 4.75, comma, let's see what we're going, 32 all the way to 48. Looks like it's going up by 4s. So 36.40. So we got 4.75, comma 40. Like I said, you need to be a little careful with these graphs because of the way they're spaced out. Let's look for another good point. I think I'm going to go with this one right here. So once again, these are going over 0.25 each. So this will be like 3.25, comma my y value, let's see, 16, 20, 24, 28. Looks like that's at 28. Okay. All right, so it's a little bit hard to do the rise over run method. You could if you wanted to. I think I'm going to go with the y2 minus y1 option. See if I can find myself some room here. Okay. I think I got some room right here. So I'm going to go m equals, once again, m stands for my slope, or my rate of change. We're going to go y2 minus y1 over x2 minus x1. Sorry for my handwriting, a little sloppy. I'll retry that. Don't have much room to work with. All right. I'm going to let that 4.75 comma 40 represent my y2 and my x2, my x, and my y2, sorry. Once again, like I said, these are just naming the points. I'm going to let this guy represent my x1, y1. Just for my formula purposes, because that's how they name points here. So now instead of writing y2, I can place it with that 40 because that's what it's representing now. And it doesn't matter. You could have named the guys differently if you wanted to, but I just decided to name them like that. So I got 40 minus my y1, which once again my y1 is indicated with that 28. So 28 over my x2, which we find is 4.75. And minus my x1, which once again 3.75 isn't being named that. So then 40 minus 28 is 12 over 4.75 divided by 4.75 minus 3.75 we get is 1.5. And if we take our calculator and take 12 divided by 1.75, we should get 8. Okay. So our rate of change is approximately about 8, using what we used up here. All right, so let's take a look at our answer choices. All right, A, we get 4 over 33. Well, if you don't know what that is, just take your calculator, go 4 divided by 33, and we get that to be approximately 0.12. You might have saw that right off the bat that that's not a good answer choice. Looking at our next one, 19 over 41. Once again, if you're pretty good with fractions, you can see that that's not a good one. This is about 0.46, not even close to 8. We got 8 and 1/4. Well, that's equal to 8.25. And lastly, 4 and 4/7, which that's about 4.57 approximately. Like I said, this isn't exact science because this one we had to kind of approximate our points. But you can see the closest to our answer is right here, 8, with the 8.25. So C would be the correct answer choice here. Like I said, some of these graphs are pretty easy. Some of them get a little complicated, like this guy right here. But just do your best, pick out some decent points, and you should get approximately your right answer choice. Moving down. It says, Fancy Flower is a wholesaler that sells exotic flowers in 4-inch pots packaged in crates holding different numbers of pots. The table below represents the cost of 4 different sizes of crates that hold different numbers of 4-inch flower pots. So we got a number of 4-inch flower pots in the crate. It's kind of representing our X values. We got 9, 12, 16, and 24. The cost of the crate of 4-inch flower pots, well, for 9 is $6.10. 12 is $7.30, 16, $8.90, and 24, $12.10. It asks us, determine the rate of change of the costs of a crate of 4-inch flower pots with respect to the number of 4-inch flower pots in the crate using the table in the graph. All right, well, this one's no answer choice, so we actually got to go just find it. Once again, make your choice. You can use these different formulas. You can go change in y or the change in x. It's one way to find our rate of change or our slope. Another one is y2 minus y1 over x2 minus x1. Once again, that's a good way to find our slope. I'm going to go with the second option right here, just for an argument's sake, just so y'all can see how it works a little bit more. And I'm going to show you that it doesn't matter which 2 points you choose. You can use any 2 points. So I'm going to do 2 different examples. I'm going to choose this one right now to represent my x1, y1. and this guy right here to represent my x2, y2. Okay, so using that, we go m equals y2 minus y1 over x2 minus x1. Looking at my y2, I see it as $7.30. It's gonna, only because I'm letting it represent y2, so $7.30 minus my y1, which in this case right here is at $6.10, once again because I'm letting it represent that, over my x2, which in this case I'm letting it be 12, minus my x1, which once again in this case I'm letting it be 9. So, doing a little bit of math here, we'll take 730 minus 610, and you can use your calculator if you need to, but it's going to be 1.20 or 1.2, and 12 minus 9 becomes 3. Doing a little bit more, we'll take 1.2 divided by 3, and we get 0.4. And see, you can represent your slope as a decimal, as a whole number, or most of the times they like to use them as fractions. So just in case, we're going to call this 2/5 or 2/5. Okay? All right. So let's remember that we got 2/5 using that method. Okay. This time, let's let this guy represent my, let's call him x2, y2 this time, just to show y'all that it doesn't matter which points I use. I'm going to let this one be my x1, y1. Okay, remember 2/5. I'm going to rewrite that down somewhere else real quick so I can give myself some room. Okay, remember 2/5 is what we got the last time. See what we get this time. So once again, m equals y2 minus y1 over x2 minus x1. Well, this time I'm letting my y2 be represented by 730 or $7.30 minus my y1, which this time I'm letting it be 1210. Once again, that's just naming the points, or $12.10. My x2 down here, I'm representing it with 12, and minus, well, my x1, which is in this case I'm letting it be 24. Okay, so doing some math here. Once again, I like to use my calculator too every once in a while. I'll get that to be negative 4.8 on the top. 7.30 minus 12.10 is a negative 4.8. Over, well, 12 minus 24, you should get negative 12. Well, then let's take negative 4.8 and divide it by that negative 12, and we'll find that we get 0.4. AKA, once again, if we convert it to a fraction, we get 2/5. So notice, didn't matter what I chose, I still got the same slope as 2/5. So my rate of change, if I express it correctly, would be, well, let's think about this real quick. X is representing, the top number here is representing my rise, and this one's representing my run or my 4-inch flower pots, while the top is representing the cost. So for every 5 inches, it goes up $2. That's one way to express it. So let's go ahead and say for every 5 inches, the cost is $2 more. Or, you know, if you want to just stick with that 0.4, you can say for every inch, the cost is 40 cents. depends on how you want to interpret it. Okay, moving on. All right, looks like our last problem. Which representations have the same rate of change? So we want to find the same rate of change of y with respect to x as the equation 3x plus 5y equals 15. So let's first find out what the rate of change of this equation is. In order to do that, we'll take it from standard form and put in that slope-intercept form. And once again, that helps us because if we solve for the y and get that on one side of the equation, we can just look at the number in front of the x, and that'll be our rate of change, also known as our slope. So to solve, we'll go 3x plus 5y equals 15. Let's take that 3x over by subtracting it over. So we want that whole number to go to the other side. So we get 5y equals, well, once again, we cannot combine these terms together because they're not like terms, so we're just going to bring them down as negative 3x plus 15. Lastly, let's divide by that 5. And we got to divide, since we're taking this side, we're dividing by 5 on this side of the equation. We have to divide by 5 on this side of the equation, but we must divide everybody by 5. So 5 goes away because 5 divided by 5 is 1, so we get 1y. Let me take them over. So y equals, well, negative 3x divided by 5. Well, it's already kind of simplified, so we're just going to write it as negative 3 over 5x. And of course, 15 divided by 5 is 3. The only part I really care about, though, is this one right here, this negative 3 over 5. So real quick, give myself a little bit of room. We're going to remember that, let me write over here. The slope, or the rate of change of this guy, is equal to negative 3 over 5. Let's compare them to everybody else real quick. Alright, so lucky for us, this guy's easy to find the slope because he's already written slope-intercept form. But he's representing slope as 3 over 5, which does not match up with negative 3 over 5. Negative 3 over 5 is completely different than 3 over 5. So option 1 doesn't work for us. This guy's written in point slope form. I'm looking at 2. He's written in point slope form. Once again, the same thing. If you look at the number in front of the x, which is right here, it says negative 0.6. Well, we take our negative 3 over 5 and we convert it to decimal form. We find that it is the same as negative 0.6. So 2 is a good option for us. Okay, so we'll check him out. He's good. Let's look over here at the graph. Alright, so here we can do rise over run. M equals rise over run for our slope, or a rate of change. And we can see, let's go from this point to this point down here, since they annotated some good points. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we go 15 down. We represent that with negative 15 since we went down 15. Over our run, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. We went right 9, so positive 9. We simplify that fraction down. Divide by 3 or use your calculator. You'll get negative 5 over 3. Once again, let's double check it with what we had before. Negative 3 over 5. So it does not match up. Once again, he's out. Looking at our table here. Once again, you can use any form you want. Let's go ahead and go with the change in y over the change in x. So m equals change in y over change in x. I think it's pretty easy to do with this one. Well, our change in y from 5 to 2, we go down 3, so we subtracted 3 from it. Over, well, negative 5 to 10, or negative 15 to negative 10, we went up by 5. So our change in x is positive 5. If you don't believe me, we can check it with something else real quick. Let's go with -4 to -7. Well, that's going down by 3 units. And 0 to 5 is going up by 5. So once again, our change in y is -3 over our change in x, which is 5. So -3 over 5, which does match up with what we found originally right here. So it looks like option 4 is a good one too. So 2 and 4 do represent the same rate of change. So 2 and 4, well, A would be the correct answer choice. Alright guys, well that's today's lesson. I hope you learned something. If not, just please review over this video or check out the other resources that I have. Thank you. Y'all have a good day.